Did you know that there's another way to divide fractions besides keep, change, flip, or keeping the first fraction, changing to multiplication, and then flipping the second fraction? Well, there is. It turns out if you get a common denominator, it's really easy to divide fractions. Now, dividing fractions, you don't have to have a common denominator. The only time you have to have a common denominator is with adding and subtracting. We don't normally do it for multiplying and dividing because we don't need it. But what if the problem already had a common denominator? Or what if you just really felt like getting a common denominator? Well, you can do division this way also. So if we take a over b divided by c over d, and we convert it to where they have BD as the common denominator. So I've just rewritten this with a common denominator. All you have to do is just divide the numerators. And what will happen is the common denominators will go away. So this is an alternative way that if you happen to be lucky enough to have common denominators, you can divide without using the other method. But again, this is just to give you options for how you want to teach it. And I'll explain why those denominators cancel as we do this first one. So let me change it to where we have a common denominator. I think a good common denominator would be 12. So I'm just going to set up my problem first of all with what I want it to look like. So 3 times what would give me 12? Well, times 4. So for this first fraction, multiply by 4. To turn the 4 into a 12, you multiply by 3. So if you have 4 twelfths divided by 9 twelfths, it's just 4 divided by 9. It's just 4 ninths. And the twelfths just drop off. Now maybe you don't like that, so that might be, maybe if that doesn't sit well with you, maybe you're not going to like this algorithm. But this is one way to do it. The reason why is because if you take 4 twelfths and you change that division to multiplication and you flip this fraction, do you see how this guy down here that was the common denominator, when he gets flipped up to the top, do you see those are going to cancel? And you're just going to get 4 ninths. So that's what I mean by those 12s just kind of fall off and you just end up with 4 ninths. Let's try another one. All right, what would be a good common denominator if we wanted to get a common denominator? I think 8 would be probably the best. So the second fraction already has an 8. I don't have to change anything there. But this first fraction I would need to multiply by 2. So then I have 2 eighths divided by 3 eighths. And if you have a common denominator, you just divide the numerators and you get 2/3. Easy peasy. One more. 2/5 divided by 4/3. All right, 15. Let's use 15 as our common denominator. So I would need to multiply 5 times 3. So I'd have to also multiply 2 times 3. Multiply 3 times 5 means I also have to multiply 4 times 5. And can you see it? 6/15 divided by 20/15. The 6 divided by 20. Now on this one though, you got to be careful. 6 and 20, those have factors in common that you can reduce. 6 and 20 can both be divided by 2. So you need to make sure that you give that as your answer. That guy needs to be reduced. So don't forget that even when you use this alternative algorithm, sometimes you might still have to reduce the answer at the end.